The thrusters on your space platform in Factorio seem pretty straightforward at first. You just pump in some fuel, you pump in some oxidizer, and they just go. But they're actually a little bit more nuanced than that. If we look at their Factoriopedia entry, we can see that the thrusters can generate thrust between 100% efficiency and 51% efficiency. What does that mean? Well, if we pump in all of our fuel and all of our oxidizer, our thrusters will deliver maximum speed but operate at 51% efficiency, or burn twice as much fuel as required. If I cut my fuel input, we can observe that as the fuel in the thrusters drops, the efficiency number actually goes up. So if only there was an easy way to control exactly how much fuel goes into these thrusters and maintain a higher efficiency. You'd think it'd be as easy as just slapping on some sort of pump, which we can control with a circuit, and just read the amount of fuel in the actual thruster. But unfortunately, you can't connect a wire to a thruster and read its current fuel levels. But that's okay, because I'm going to give you a very simple workaround. But first, we need to understand the concept of a clock circuit, and here's how it works. To make a clock circuit, you want to start with a constant combinator. You can set the signal of any channel, for example, channel A, to be a value of 1. Next, we want to put down a decider combinator. We want to run a wire from the constant combinator into the input section of the decider combinator. Open your decider combinator and set the condition for the input to be A is less than 60. This tells it when the input signal of A is at a value under 60 that it will continuously send an output signal. We want the output to be the same as the input signal, so set this to channel A as well, and now it will output the same signal as it gets from the constant combinator. At the moment, nothing is happening, but the magic happens when you wire the output of the decider back in on itself. Now we can see that the value of A is incrementing up to 60 in ticks of 1, and when it hits 60, it resets itself. Essentially, we've made a clock or a timer. Wiring this output into any machine can allow us to control its on and off frequency very precisely. For example, if I wire it into this lamp and I set the lamp to read on channel A and have the condition, for example, greater than 30, the lamp now turns on and off on a timer. If I set this value to a higher number, such as 50, the lamp's on duration will be shorter. Conversely, if I set the value to something low, like 10, the lamp's on duration will be longer. The astute among you will have already realized, instead of wiring this to a lamp, we can wire this to a pump. This will allow us to pulse the fuel into our thrusters in small bursts instead of one continuous stream. Without going into the complex maths of how thrusters burn fuel, essentially we've created a circuit where we can set the value on the pump to be greater than a number that we choose, and that number will now exactly control how much fuel is in our thrusters. For example, if I set this condition to be A greater than 40 and I let the thrusters consume all the fuel in the pipes by letting my game run faster, the fuel will eventually drop down and level out at a specific number. In my case, with these 5 thrusters and the value set to 40, the thrusters will maintain a fuel level around just over 50% and maintain an efficiency of around 66%. Setting this value to a value of 50, for example, will now lower the amount of fuel in the actual thrusters. It's maintaining around 33% of a tank and running at about 85% efficiency. You can increase this even more to 55 out of the total 60, and it will go even lower and go up to 93% efficiency. Of course, when you park your ship, the thruster's fuel will fill up again because it's not being consumed, but whenever you go again, it'll eventually burn that fuel and level it out at exactly that same amount. Fantastic. So I recommend you play with this number and set it to a value, in my case probably around 50, so that you can achieve a decent speed but also burn fuel at around an efficiency of 85%. Now, if you need more speed, I recommend you just add more thrusters, but still burn at a better efficiency. For example, I can just add 2 more thrusters to get my space platform going a lot faster. But adding 2 more thrusters will have reduced the amount of fuel because this number is still the same. So I can just play around with this number. For example, if I lower this now to 42, I am maintaining about 80% efficiency, but my top speed has increased to somewhere between 220 and 250. Anyway, the point is we have created a tiny little logic circuit with 1 constant combinator, 1 decider combinator, and a little bit of wiring. But this one value in here now completely controls how much fuel we want in our thruster, allowing you to precisely control the fuel efficiency you want and the top speed that you want to achieve. It is worth noting that in your actual game, you will need to probably set this up on both your fuel input as well as your oxidizer input, because in reality, you'll never be able to guarantee that both of these have an infinite source and will always be in surplus. Sometimes you'll have less oxidizer and then fuel, in which case the system won't work. So make sure you have the condition set up on both your fuel line and your oxidizer line. And that's it, guys. A very, very simple logic circuit to control your fuel input. If you've learned something, don't forget to leave a like and subscribe. And if you're looking for something to watch in the meantime, consider checking out my Space Age Let's Play series. Thanks for watching.